Hello, dear students. How are you all? I hope you all are doing well today. Have you ever seen rush from an iron? Watched a candle burn? These are everyday examples of chemical reactions happening all around us. Today, I will be discussing chemical reactions and equations. What they are, how they are work, and why they are important in our daily life. These are today we will learn. But before we get into the details, let me briefly introduce myself. I am Vyasarani. I have pursued BSc B.Ed and I have pursuing MSc Physics. I have been working as a teacher for the Prodigies International School for past 3 years. What is chemical reaction? The process in which new substances with new properties are formed from one or more substances is chemical reactions. The substances which take part in chemical reactions are called reactants. The substances which are formed in a chemical reactions are called products. Example: digestion of food, respiration, rusting an iron, burning of magnesium ribbon, formation of curd. These are example of chemical reactions in our daily life. What is physical change? Those change in which no new substances are formed are called physical changes. In a physical change, the substances involved not change their identity, but the change in physical state, physical size and shapes of substances are physical change. Next, chemical change. Those changes in which new substances are formed are called chemical changes. In a chemical change, the substances involved change state identity, take it converted into entirely new substances. One activity they are given in the textbook: burning of magnesium ribbon in collection of magnesium oxide in a watch glass. We must have observed that magnesium ribbon burns with a dolphin white flame and changes into white powder. This powder is magnesium oxide. It is formed due to the reaction between magnesium and oxygen present in the air. Magnesium and oxygen present in the air, it will come magnesium oxide. What are the chemical reactions of characteristics of chemical reactions? Change of state. Change of state. How? When hydrogen gas reacts with oxygen gas, it's result in formation of liquid, water. It will come water. How it's change in color? When iron nails is dipped in blue colored copper sulfate solution, the blue color change into green color. When sodium reacts with water, bubbles of hydrogen gas is seen. Change in temperature. How? When water is added to quick lime, the vessels becomes warm due to evolution of heat. When potassium hydroxide is added to ammonium chloride, the vessels becomes cold due to absorption of heat. How? Formation of precipitation. When silver nitrate solution reacts with sodium chloride solution, it gives precipitate of silver chloride and sodium nitrate solution. Next, balancing chemical reactions. Balancing chemical reactions, it means when the number of atoms each element is the same on both sides of the equation. It is called balanced equation. It depends on law of conservation of mass. In a chemical reaction, mass is neither created nor destroyed, meaning the total mass of the reactants equals the total mass of the products. What is reactant? The substances that react with each other in a chemical reactions. This is left side of the equation. What is product? Products the substances that are formed as a result of the chemical reaction. This is right side of the equation. Right side of the equation is called products. Left side of the equation is called reactant. Example, consider the reaction of hydrogen and oxygen to form water. Reactant, hydrogen and oxygen. It will come water, liquid, H2O. This is the product. In this balanced equation, there are 4 hydrogen atoms on the both sides, 4 in reactants, 4 in products. Hydrogen, 4 hydrogen in reactants, 4 hydrogen in product. There are 2 oxygen atoms in both sides. Oxygen, reactant side also 2 and product side also 2. This is the example of balancing chemical equation. Another example, the balanced chemical equation for zinc reacting with dilute sulfuric acid to produce zinc sulfate and hydrogen gas is zinc sulfate and H2SO4. Zinc sulfide and hydrogen gas will come. This equation demonstrates that one zinc atom reacts with one sulfuric acid molecule to produce one zinc sulfate molecule and one hydrogen molecule. For example, reactants zinc and dilute sulfuric acid are the starting substances in the reaction. Product, the reaction produces zinc sulfate and hydrogen gas. What are the balancing? The equation is balanced because it shows the same number of atoms of each elements on both sides of the equation. Zinc atom on both sides, one zinc atom on both sides, 2 hydrogen atoms on both sides, 1 sulfur atoms on the both sides, 4 oxygen atoms on the both sides. This is the balanced chemical equations. Types of chemical equations. Next, types of chemical reactions. The basis for different types of reactions is the product formed, the changes that occurs, the reactants involved, and so on. Different types of reactions: combustion reactions, decomposition reaction, neutralization reaction, redox reaction, precipitation or double displacement reaction, synthesis reactions. These are types of chemical reactions. Decomposition of reaction. The decomposition of mercury oxide into liquid mercury and oxygen gas is shown in here. This reaction was an important one in the history of chemistry because it helped early chemists to understand the relationship between reacts and products. In the last lesson, we began investigation how a chemical equation can be represent given chemical reaction. In this lesson, we are going to study of the way in which chemical reactions are classified. There are literally thousands of chemical reactions that takes place every day in our life. Some reactions take place in the atmosphere, such as the combustion of fossil fuels. Combination of reaction. The first type of reaction that we will investigate is the combination of reaction, which is sometimes also referred to as a synthesis reaction. In combination reactions, 2 or more chemical species combine to produce a single new compound. A generic combination reaction might have the following form: A plus B is give rise to C. Means substances in all state of matter can be participate in combination reactions. For example, oxygen in the air can react with iron to produce rust. Rusting is common occurrence, especially in a region of the world where precipitation is relatively high. Although rust tends to be mixture of compounds, its primary component is iron oxide. Rusting is generally a very slow process, but when the iron has very high surface area, as in the case of steel, wool, it can happen at a much faster rate. Combination reaction, two or more reacts combine to form a single product. For example, hydrogen and oxygen. Two hydrogen atoms, four hydrogen atoms, and two oxygen atoms. It will come water. Hydrogen reacts with oxygen to form a water, also known as synthesis reaction or combination reaction. The balanced chemical reaction for this process is shown below. Iron, 4 atom of iron, 6 atom of oxygen gas. Ferric oxide, it will come ferric oxide. Next, decomposition reaction. The decomposition reactions is the exact opposite of combination reaction or synthesis reaction. Decomposition reaction, a single chemical species breaks down to produce two or more new chemical species. A generic decomposition reaction might take the following form: C gives rise to A plus B form. Again, substances in all state of matter commonly participate in decomposition reaction. For example, hydrogen peroxide will decompose over time to produce water and oxygen gas according to the following equations. Hydrogen peroxide, it is the liquid. It breaks down water and oxygen gas. Another common type of decomposition reaction involves the process of electrolysis, in which an electrical current is passed through a substances to break a part of compound. One example of decomposition reaction requiring the uses of electrolysis is the decomposition of molten sodium chloride. As shown by the following equation, sodium chloride, it will break sodium and chloride gas will come. Next, single replacement reaction. A single replacement reaction, sometimes called single displacement reaction, occurs when one chemical species of one single element replaces a portion of another compound to produce two new products. The general form of single replacement reaction is shown in below. AB plus C, it gives rise to EC plus B. Two common type of single replacement reaction involves pure metal reaction with aqueous solution of either an acid or an ionic compound. When a reactive metal is placed in an acid solution, the following reaction is likely to occur. Metal plus acid, its breakdown, it gives rise to ionic solution and hydrogen gas. An example of this would be the reaction between zinc and hydrochloric acid, which produce zinc chloride and hydrogen gas. Here is an image of this reaction. Single displacement. One element replaces another in a compound. Zinc displace copper in copper nitrate, also known as replacement or substitution reaction. The balanced chemical reaction for this single replacement reaction is this equation. Zinc atom and hydrochloric acid, it give rise to zinc chloride and oxygen gas will come. Another type of single displacement or replacement reactions involve a solid metal replacing the metal cation in an ionic compound that has been dissolved in water. If the solid metal is more active, more reactive than the dissolved metal cations, the following type of reaction can occur. Metal plus ionic solution, different metal, different ionic solution will come. Another type of single replacement reaction involves a solid metal replacing the metal cation in an ionic compound that has been dissolved in water. If the solid metal is more reactive than the dissolved metal cations, the following type of reaction can occur. Metal plus ionic solution, It's give rise to different metal will come, different ionic solution will come. A common example of this reaction, when iron is replaced by the more reactive zinc metal, the balanced chemical equation for this process, zinc and ferric sulfate. Ferric sulfate solid will come, zinc sulfide. It's give rise to iron plus zinc sulfate will come. Double replacement reaction. Double replacement reaction typically include two water soluble salts and reacts with one another in solution. The general form of double replacement reaction would look something like the following equation. This is the general equation. AB plus CD is give rise to AD plus CB. In double replacement reaction, the cations from the original two ionic compounds trade anions to make two new ionic compounds. In general, at least one of the new compounds must precipitate from an insoluble solid for us to conclude that a reaction has occurred. An example of such a process is shown below with the double replacement reaction between solution of potassium iodide and lead nitrate. This is potassium iodide and lead nitrate in this picture. Double displacement reaction, two compounds exchange. It's simple. Double displacement reaction, two compounds exchange ions to form two new compounds. Silver nitrate reacts with sodium chloride to form silver chloride and sodium nitrate. Often involves the formation of precipitate, gas or water molecule. Combustion. Combustion occurs when a hydrocarbon reacts in the presence of oxygen to produce water and carbon dioxide. These reactions are very exothermic, which means that they produce a large amount of heat. Combustion reactions are quite common in our everyday life, such as the burning of gasoline to fuel a car. The chemical equation for combustion reactions is the following. Generic form CHHY plus O2. It's give rise to water plus carbon dioxide. Combustion reactions of marshmallow, sucrose or wood cellulose. The process of cellular respiration can be thought of as a highly controlled version of a combustion reaction. We do not literally burn hydrocarbons in our body, but the overall reactants and products are the same. Hydrocarbons such as sucrose formula C12H22O11 are combined with oxygen in series of enzymatic steps to product water, carbon dioxide and energy, which is stored in the form of reactive molecules. The unbalanced chemical equation for this overall process, this is shown in sucrose plus oxygen. The carbon dioxide, it will come carbon dioxide and water. Next, oxidation and reduction. What is oxidation? Oxidation is understood as the loss of electrons or the addition of oxygen or the removal of hydrogen, while reduction is the gain of electrons or the removal of oxygen or the addition of hydrogen. This is called reduction. Oxidation, loss of electrons. When a substance loses electrons, it becomes positively charged and is said to be oxidized. Addition of oxygen. If oxygen is added to a substance, it's considered oxidized. Removal of hydrogen. Similarly, if hydrogen is removed from a substance, it considered oxidized. Reduction means gain of electrons. When a substance gains electrons, it becomes negatively charged and is said to be reduced. Removal of oxygen. If oxygen is removed from a substance, it's considered reduced. Addition of hydrogen. If hydrogen is added to a substance, it's considered reduced. Example, consider the reaction between zinc and copper ions. Zinc losses, in this equation we have to observe zinc and copper 2 plus ion. It gives rise to zinc 2 plus ion and copper will come. Means zinc loses electrons and is oxidized zinc. Copper ions gains electrons are reduced. This is redox reaction where zinc is the reducing agent and copper ions are the oxidizing agent. Effects of oxidation in our daily life. Corrosion. When a metal is exposed to moisture, air, acid, etc. for some time, a layer of hydrated oxide is formed which weakens the metal and hence metal is said to be corroded. Rusting of iron, black coating on silver and green coating on the copper are examples of corrosion. Corrosion can be prevented by galvanization, electroplating or putting paints. Rancidity. The oxidation of fats and oils when exposed to air is known as rancidity. It leads to bad smell and bad taste of food. Methods of prevent rancidity by adding antioxidant, keeping food in airtight container, replacing air by nitrogen, refrigeration. These are methods of prevent rancidity. These are chemical reactions and equations.